Hi, it's Rob here, and we're going to have a quick look at automatic query tuning using Ebean's Auto Tune feature. What we're going to do here is run some queries and profile them and automatically tune them to reduce lazy loading and to only fetch what the particular application uses for those queries. What we've got here is a query, and if we have a look in here, it's just going to find orders using the statuses and do an order by clause there. And this query is actually going to be used in a couple of places. We've got it used here in test other method, but we've also got it used up here. So this query is going to be run ultimately by these two different methods with two different object graph usages. So let's have a look at our simple one. So we get a list of orders back, and we read the order date, ship date. We get the customer and read the customer name and comments. Now, before we turn on automatic query tuning, let's just run this query. And the first thing I want to point out here is that when you look in logging for Ebean without automatic query tuning or auto tune, you'll already see summary logging. So you'll see logging for org of RG Ebean sum. And in there, you'll specifically see that there's an origin attribute, which has got this sort of funny code here. And that's an origin code. And we can see that this code here is the same as this code here. So you can see that that's the same code. What that means is that this is actually referred to as the order. In Ebean, we sort of call this the origin query. And this is a lazy loading query that's fired that actually is linked back to that origin query. So this is our first query for order. And then if we look over here, then this is actually a lazy loading query for customer, linking back to that origin query using this key here. And the load path was customer, and the customer name was the property that triggered the lazy loading. So if we have another look at a more complex example, so let's fire this one, run this query. So here we've got our origin query, if you like, and this code here is repeated here and here and here, and these are actually lazy loading queries that are firing. So we fetch the order, and then at some point we lazy load the customer, and at some point we lazy load the order details, and then we lazy load the product. And if we go along here, we would see that this is the path relative to the origin point for that lazy loading. So even without automatic query tuning, you can probably do some analysis using the summary logging and see and observe lazy loading queries and how they relate using the origin key back to the origin query. Now let's try some profiling stuff. So let's turn on profiling. I've got a property here. Ebean auto tune profiling, it was true. And let's run one of our queries. Actually, let's run this guy. So this was our first query that I showed you, which was the finding orders and then lazy loading customer. Now with query profiling running on, auto tune profiling running, when the application stops, a profiling XML file is output, and so we can see that here. So we have a quick look at that. Let's have a format that. So here we can see our origin key. We can see that we were querying for orders, And what the detail here is this is the query that would automatically tune that um, call for us in an optimal way. And the original here is the original query in the sense of its select and fetch attributes, and there are none, so it wasn't a tuned query, which is why we saw the lazy loading, for example. And then here we can see the call stack. So if we looked at, order find test line 61, we'll see that that's the line of code that fired that query. So what we'll do now is we'll convert this profiling into a tuning auto tune file. So we're just going to do it manually, auto tune.xml, and we're just going to get rid of this profile new. Basically, profile new means that there wasn't an existing profiling query defined, and so that was a new entry in terms of profiling. Anyway, we've created our auto tune. It's got this one entry in it here. So it's basically got this key, and it says when we use this origin key, uses this query here to automatically tune the query. So if we turn on query tuning or enable it, then when we run the query again, it'll tune. Now, just to state there that profiling and query tuning are fairly independent, or are independent. You can profile without tuning, and you can tune without profiling. So anyway, let's run our query again, and let's have a look. So first of all, we see this. This is our query here. We've got query order, and we can see that there's another attribute here, kind of tuned equals true, and this is our origin. And what we'll see is that there is now a join. We look across here, join to customer, and there's no lazy loading query going on here. And also there's another entry here saying there's no new or diff entries for profiling. So basically, when we're shutting down the server, the profiling is checked against the tuning, and if there are no differences, that's the message you'll get. There's no differences between what's run. Okay, so what we'll do now is we will run. Let's say we run all of our queries. So this test actually has three methods, if you like. So it runs three queries. So one of them will be tuned, and two of them won't be. So we'll see here auto tunes loading one tuning entry, and here we see an origin point, and if we look for that, we can see that there's a lazy loading query here for this origin. So it's finding orders and then lazy loading customer and order detail and product. We go down a little bit more. We're seeing another query here, and more lazy loading occurring, customer and order detail, etc. And at the bottom here, we've got our tuned query, which is good. So anyway, what else have we got? We've now got a new profiling entry. Let's have a look at that. So at the end of the log here, it says writing two new entries into the profiling. So if we look at our profiling, the profile XML document contains, if you like, three sections: a profile new section, a profile diff section, and a profile empty section. So we haven't got the other two at the moment, but we've got two new profile entries, and they're saying when you run this query, well, basically this is the optimization for this origin point, and similarly this is the optimization for this origin point. So let's just grab those. copy and paste them in a very high-tech manner into our tuning file. Right, it's all good. So when we looked here, we could see lots of lazy loading and etc. Let's just run that again. And what have we got? So here we've got our tuned query, another tuned query, and we've got a select count star. Now, it's possibly not obvious, so let's make it obvious that some queries are not interesting for auto tune, and specifically select count star and delete queries and find IDs. So those things don't have object graph. They don't have. They just have IDs or counts. And so in terms of object graph usage, they're not interesting. So auto tune just ignores all of those types of queries. So we've got our tuned queries, and we've actually got 3 of them here. 1 here, 2 here, and we'll have another one down here. Now, I just wanted to point out that one of these queries actually has a plus query, a secondary query. So, although we've tuned this query here, we've actually got a second select statement firing. Now, why is that? Basically, in terms of object graph queries, an object graph query has to be broken into multiple SQL queries in order to avoid producing SQL Cartesian products, and also to always honor a first rows, max rows paging paging anyway. And the reason is because first rows, max rows is based on relational paging, so that's row based and not object based. So pretty much those are the 2 reasons, or there's actually a 3rd reason why Ebean will automatically take an ORM query and break it up into multiple SQL queries. So it does that for performance reasons, to avoid SQL Cartesian product and to always honor first rows, max rows. So always honor the paging query. So in this case, Ebean's done that for us here automatically. And what this means is that pretty much doesn't matter what the select and fetch clauses are, Ebean will never do something stupid, basically, which is good. Now, let's have a quick look here at what we've got, because there's another interesting aspect to this. Let's do a diff first. So now let's go back to our query and our code and change it. So we've got our other here. Let's actually just not read comments, for example. If we run this again, and let's have a look at we've got a new profile file. Let's have a look at that. In this case, we've got a profile diff. So let's just format and just add a couple of spaces there. So when we get a profile diff, what this is saying is that what's being profiled is different from the tuned query that we're using. So this is the profiling, and the profiling here doesn't have comments, but our tuned query does. So what we're saying is that we won't actually see an extra lazy load query. We're just fetching a little bit more than what the profiling says is optimal. So we could, for example, include that. We'll reflect that back into our tuning. Let's just change it again. Add some more stuff. So for this case, we're going to add reading some attributes. I'll run that again. So it's going to run all 3 queries. Got another tuning one. And let's format that. Okay, so Okay, in this case, we can see that comments is not, the tuning says that comments is not required, but the tuning now says that we actually should fetch customer contacts, the first name and last name for all the contacts. So actually, if we looked at our run, we would see a lazy loading query kicking in here. So where do you see that? Ah, here it is. So this should be our origin point, and this should be contact, which it is. So we've gone to customer contacts, and that's fired a lazy loading query, bringing in the customer contacts, I should say. Now, if we just took this entry here and said, okay, let's take that and apply that into our profile. So this is CE blah blah. This looks like it. Yeah, there we go. Okay, so we're now tuning. So now if we run that again, let's have a look here. We don't see our lazy loading query, and actually at the bottom here, scroll baby, here we go. No new diff entries. So that's all good. Now there's one other thing to talk about, which is let's take one of these queries, rather large ones, which is this one here. This query fetches customers, but also details and detail products, etc. Now we can actually put plus query in there, or actually plus lazy, right? But let's put plus query. And what that is saying is that although we're tuning this query, we want to explicitly break the query up into multiple SQL statements. Now that comes down to control. There'll be some graphs that are quite complex, and the way that a complex graph is loaded affects the performance, and you want to control specifically how a complex graph is broken up into multiple SQL statements. So you can add in plus lazy and plus query in order to do that. And why would you add in plus lazy? The reason why you can do that is that, and we might make this more explicit and say something like this, L2 cache, some parts of the object graph, and in fact, let's do that. We might say, actually, when we fetch customer, we want to do it lazy, and what that will do is that will hit potentially the L2 cache if there's an L2 cache set up for customer caching. And so what that means is that you can control how to break up, using plus lazy and plus query, how to break up the object graph construction, and also potentially populate some parts of the object graph from L2 cache and, and shortly L3 cache being Elasticsearch or a document store. So if we ran that, let's just run all of them. We just need to find that, but that shouldn't be too hard. So in here, we've got a plus query for order details. So we've got our origin query here, and that's fired a secondary query fetching the order details, and that's what we explicitly put in there. And also we've got a lazy loading of the customer. So that wasn't particularly sensible in this case. Was probably not a good idea. But if we wanted to load part of, for example, customer from L2 cache, it might have been a good way to do it. So that's pretty much it. there's a bit more to tuning in the sense that populating auto-tune in a sort of a nicer fashion, but the guts of it is that profiling can run independently of tuning. So let's to show that quickly. What that means is that, let's say we go in and we say, well, actually in production we don't want any profiling at all, and instead we only want query tuning. In this case, Ebean will start up, it will load the tuning file, and it will tune what's in the tuning file, and it won't collect any profiling information. So that's a reasonable way to run things in production. You could still run profiling in production. What profiling is set up to do by default is to profile the first 5 queries for any particular origin point, and then after we'll profile 1% of queries, so 1 in every 100 queries. So it's relatively lowish overhead, if you like. So certainly that's quite doable in production, but you might want to also just do that. And if we ran that, then we'll get profiling, we'll get tuning, but we won't get any profiling running. So that's a reasonably quick introduction to AutoTune. There is configuration control over where these files are loaded from, etc. The default is Ebean autotune.xml, just straight from the working directory. So I'll leave it at that. Cheers. Oh,